The Boolean library Blender uses is an interesting mix between surface and volume calculations at the same time. So if I add, for example, a volume, let's say a cube, I can cut this cube by using this plane. So for example, Boolean difference with this plane. And you see wherever this plane is, I see my cube cut. And again, the object normal defines the direction of this result. If, for example, I add a little bit of volume to this cube, let's make sure the normals are out, you can see that now instead of cutting one part completely away, I actually cut a complete volume out. So with a plane, you basically trim off, and with a volume, you cut something out. So this also means, for example, if I switch this to intersect, I will maintain the intersecting volume of these two volumes. And if I say union, I will get the result of these two volumes calculated together. There you see how the inside is hollow. Okay, so some rules for example, the union and the split. So when I do union, I can move this one down till there, and you see it always results into a little bit of two volumes that are overlapped or intersecting, and it just calculates it together. If I say difference, here we see how this part is cut out. However, if I now actually select this plane and not plane, cube, and turn it into a plane, you see that this mesh goes into the object but doesn't really cut through. And when I exit edit mode, you see we get a miscalculation. So this seems not really to work with intersect or union. How does union look like? Yeah, when we get something like this. So this this result here is wrong and useless. And the main reason for that is this plane really has to fully intersect with the part we want to cut through. You see, the moment it's not really intersecting, we get a miscalculation. So whenever you work with a Boolean command and a volume to add or cut something out, it can partially intersect into the object. However, if you want to completely trim something off, you need to have a surface, like in this case, that perfectly intersects with the object. So think about it like a knife that has to cut through a complete string of dough if you want to make cookies. You can't simply cut a little bit into the dough and expect one slice of cookie dough to fall off. Okay, so other situation. Let's say we have something like this. Let's say we make a cube and we make a circle. And then the circle we scale down there and scale this one up. Okay, so you see the circle perfectly penetrates the cube, Boolean, and intersect, and properly will maintain the outside because my circle is flipped. So I can flip the normals. Now I maintain the inside. And here the same rule applies, is the moment this circle is not fully like a knife completely cutting through the object, at one point I might get a miscalculation. As you can see here now, I actually end up kind of like with an open object, while this is actually the cube. So in the moment this perfectly intersects, you see I get the opposite. What do we have here now? There, yeah. So you see actually with this mode, so I say difference, there is nothing that actually defines this cylinder to be capped. So what the Boolean calculation is doing, it says difference where maybe these two surfaces intersect, and that's along this perimeter. And then the depth of the cylinder, it goes in, it adds a new extrusion, but because there's no cap to the cylinder, it leaves this one open. So this means actually when we go ahead and, for example, cap this, so with F, there, it caps it. So this means, as you can see, I do not need to have a complete fully capped cylinder to do, let's say, a solid subtraction of a volume. So if I cap this one or not, in this case, doesn't really matter for the cut. But let's say what happens when we say union. Yeah, then we get actually something like this. So the two meshes are fused together, but because the cap obviously is not there, also my result here is open. So to do something like this, then obviously we need to also cap, oops, wrong command, cap this part. And then you see this is nicely fused together. So it's kind of like a mix between surface trimming and solid manipulation with some extra rules or capabilities. So let's see what happens, for example, if we have just a plane, and for the plane there we add a cylinder. There, E and Z, Control N. Okay, so this plane, I would like to add a Boolean command. So difference, and probably what will happen is exactly it just for the length of the cylinder, how far it intersects, it creates then the side face, but because the cylinder is open, it doesn't add the cap geometry. So here the same, I can actually say, well, cap it. And then you see I can push into a surface actually this other part in, and it, because we say a difference, it uses this mesh, cuts out the volume of the cylinder, and for how much the cylinder intersects with the plane, it uses or displays then the mesh of that cylinder. Pretty useful. So let's say we do a reverse. So we actually would like to add a Boolean command to the cylinder. And you will see that in this case, because the face completely intersects with this hollow cylinder, it cuts the top off, and then it also caps it at the same time. This is, for example, a very useful command when you work with fonts or a logo, and you extrude the sides up, and then we put a top surface over it, and then we just trim and cap it. So in Alias, for example, we would have to trim the cylinder, and then we have to trim the face, so the outside. So we maintain the trimmed cylinder and the trimmed plane. And in Blender, with the way how the library works, we can simply intersect these two objects and kind of use a Boolean solid command, but because it's a hollow object, so surfaces, we kind of get this result. So we save actually one step. The nice thing is I can simply use this one, move it up and down, and it updates actually the way how the cylinder will be capped. So if, for example, we would like to add another cylinder there, let's say we scale this one down, there, E and Z, move this one up, and say U Boolean difference, this one, there's, we cut something in. if, for example, we would cap the bottom part, and then we also cap actually the Boolean result. See now it's capped. Well, what happens actually if we cap also the top? So fill. It does something like this, because we simply say, well, this whole volume just cut out. No? So there's no big difference. But if we now actually open the bottom part, let's see what will happen. We get this. So it doesn't really go up to anywhere else. But if, for example, the bottom part we fill, so now this is actually a volume there. And for example, there, sorry, my fault. This actually does not need to be capped. I would like to, because this volume we still cut out, so instead of difference we say union. Let's see what will happen. And there you see, because we said union, so we actually simply add this mesh to actually that result. And if we move it to here, you see there's no logical outcome, while actually we added to it in 3D space. So that actually can work, because with union it's simply adding that volume. But obviously it makes no sense to move it up to there. But if the moment, for example, it intersects there, you see like it has to be there, then we get the true results. The moment it slightly intersects with the surface, there is something happening, and that's not a good result. So this one has to perfectly intersect with this face, and then we get this result. Okay, and that's kind of like the way how the Boolean modifiers work in a nutshell. So it's all about calculating volumes together, or subtracting volumes, or keeping the intersecting volume. And Blender has the ability to do volume calculations just also with flat surfaces, which then will simulate or work a little bit like two-step trim surface command like in Alias.